Alright, let's do some Mathity-Math. It says here, Conway the Clown is an amazing juggling phenom. He can juggle any number of chainsaws, ninja stars, and bowling balls as long as they are proportioned in a specific way. Alright? For every one bowling ball Conway the Clown is juggling, he can juggle 17 ninja stars and 5 chainsaws. That sounds amazing. Alright. Let's go to part A first. It says, write the expression that will always show the total number of objects Conway the Clown is juggling. All right, let's tackle A first. So when we look at this story up here, it's a great story, but the information we really need is right here. So for every one bowling ball that Conway the Clown is juggling, he can juggle 17 ninja stars and 5 chainsaws. It's all gonna hinge on understanding this. Okay, so let's move down here and let's kind of process what's happening. So there we go, got all we need. So when we look at this, we're looking for the total number of objects. So if we kind of made a table to just kind of model some situations here, I'm all crooked, sorry. Okay. We could think of it like this. All right, so we have one bowling ball. So I'm going to put BB stands for bowling ball. So if we had one bowling ball, right, it said we got 17 ninja stars. So I can put ninja stars. Okay, and what's the next one? Oh, 5 chainsaws. But if you think about it, we're trying to find the total number of objects. So 1 plus 7 is 18, and 18 plus 5 is 23. And if you just do a couple iterations of this, you'll kind of see the pattern, and you'll get good at these problems, and you can push through them a bit faster. So you don't have to draw this table every single time, but just so we know what we're doing, it's not a bad idea. So if he had 2 bowling balls, because everything really does hinge on bowling balls, well then you have to double this, like times 2, so that would be 34. This would be 10. And if you add all those up, they would be 46. And at this point, if you kept building this pattern up, you would do 17 times 3, which I believe is 51. And then 5 times 3, which is 15. And if you added those all up, let's see, we got 5, 6, 7, 8, 9. We get, all right, 69. And you kind of see that it just kind of builds and builds and builds and builds. And in essence, what we have here is that because everything hinges on the one bowling ball, it's all about the question of like, well, how many bowling balls? And we don't know. And when we don't know something in math, we represent that as the variable, and so we can call that x. So what we could think about this, for instance, is if you kind of worked your way up, 17 times 1 is 17, 5 times 1 is 5, and 1 times 1 is 23. I'm sorry, 1 times 1 is 1, but if you added all those up, you would get 23. So using that same idea, right, if the x value is 1, that's what happens. So if the x value is 2, 17 times 2 is 34. 5 times 2 is 10. If the x value is 3, same idea, 17 times 3, 5 times 3. So in essence, what we kind of get here is that we just represent the bowling ball as x. We can say that's x. And then we could say, well, the ninja stars are then just going to be 17 times x. Okie dokie. And the chainsaws are just 5 times x. And if you added all those together, you would get 23x. And then whatever that x value is, or whatever that bowling ball value is, you substitute in, and you would always get your total numbers. So it says write an expression. I'm actually going to write, okay, so if I wrote the expression, it would be 23x. And if I want to be a little bit more clear, we can say, well, the total number of objects will always be 23x. And I guess technically that's an equation, but you get the point, okay? So there we go. Some good looking answers right there. Okay, so now we have like a really great question. It says, well, wait, hey, what if Conway the Clown is juggling 391 objects? How many of those were bowling balls? How many of those were ninja stars? And how many of those were chainsaws? Now, hypothetically speaking, you could just keep on building this table and keep on doing all this math and all this math. And eventually, you would get to 391. And then when you get to 391, you would find your values. But we don't have to do all that. We can actually, let me draw a line here. We can actually kind of really approach this algebraically, save ourselves some time, and go from here. So think about this. They said the total is 391. So they already told me, hey, that total is 391 objects. But up here we said, the total is 23x. And now this kind of goes off this really kind of fundamental concept that seems obvious, but it does maybe break things open for everybody. If you say, you know what? I know that T is T, right? T is T. That makes sense. I am I, you are you, he is him, she is her, right? It's just the same thing. So I can say, well, T is 391 and T is 23x. And you're both correct. So instead of this T, I substitute in 391. And instead of this T, I substitute in, this T, I substitute in 23x. And we're just doing basic substitution. Now to solve for x, I divide both sides by 23. I'm going to bust out my handy dandy calculator here. 391 divided by 23 gives me 17. So basically I just divide both sides by 23. That cancels and we get x is 17. Okay, we are not done, but we're really close. So x, we said x is bowling balls. So we know for this one there would be, so it says how many of them are bowling balls? Well, 17 are bowling balls. And so you take this x and you just substitute in. So like right here, that was bowling balls. Instead of x, I wrote 17. So here, I just do 17 times 17. Okay, again, I don't really have that in my head, so I'm just going to say 17 times 17 on my calculator. That's 289. So now I know that ninja stars, there are 289 of those. And then the last part said, what was it? Oh, chainsaws. Yeah, of course chainsaws. So again, I go to my chainsaws, and so I just do 5 times 17. 5 times 17, and I get 85, right? And these are your values. This amazing clown is juggling 17 bowling balls, 289 ninja stars, and 85 chainsaws. And I really kind of encourage you guys to take a second and make sure you're not making a silly mistake. And let's talk about how we can do that. They said, hey, it's 391. Okay, cool. Let's just check and make sure this all adds up to 391. So 17 plus 289 plus 85. Boom, 391. Math checks out. You did good work, and we are done. As always, if you want to be alerted when we make new problems, go ahead and subscribe. And if you got any questions you want me to make or some funny story problems you want me to write, just leave a comment below, and I'll do my best to get on that. Bye.